Hello students, welcome to section 1.2, linear measure. Line segment can be measured because it has endpoints. So what does this mean? Endpoint on the left and on your right. And if you take a ruler, and I'm actually doing this physically, I have a piece of paper, and if I measure the distance between point A and point B, I can conclude that the length of segment AB is equal to 5 and 4/10 centimeters. Okay? So line segment, we can measure it. The second definition, betweenness. To say that a point is between two other points, all 3 points must be collinear. And please recall, collinear points lie on the same line. So, we have 3 points on the same line, x, y, z, but it's very important to say that the point y is between points x and z. So now we can write this. The length of segment xy plus the length of segment yz will be equal to the length of segment xz. This may be a little abstract, but let me give you an example. Let's assume the length of segment xy is 4 units. Let's assume the length of segment yz is 5 units. Do we agree that the length of segment xz will be equal to 4 plus 5, which is 9 units? Okay, so now let's take a look at one example. Find the length of segment xz. Assume that the figure is not drawn to the scale. What does this mean? If you technically take a ruler and measure the segment, it doesn't have to be 4 5/8 inches. Okay, so how do you calculate the length of segment xz? We know that xz is equal to xy plus segment yz. Okay, now if you substitute, xz will be equal to 4 5/8 plus 2 1/2. Okay, now to add fractions, I will find common denominator. You can do this in a different way, but one way to do this is 4 5/8 plus 2, and I can rewrite 1/2 as 4/8. Okay, 5/8 plus 4/8 is 9/8, which is also 1 1/8. 4 plus 2 is equal to 8, so your final answer will be 9 1/8 inches. Okay, so this is the length of how long segment xz. Now please take a moment and try the next question. Find the length of segment LM. Pause this video and then watch me doing this problem. Okay, so in this example, I have find the length of segment LM. So I am looking for the length of this segment. That's segment LM. Assume that the figure is not drawn to the scale. Okay, so if I write the equation, betweenness of points, segment LM plus segment MN is equal to the length of segment LN. Okay, now let's substitute and let's solve for the unknown. LM, we don't know this. If you want, you can put x here, if that's helpful. Okay, so this will be x plus the length of segment MN is 2.6 centimeters, 2 6/10, and the length of the entire segment LN is equal to 4. And now you are probably aware that just to get x by itself, move 2.6 to the other side. So in other words, x is equal to 1 4/10. And please do not forget to include units, and the units are centimeters. Okay? Okay, so our next example is algebraic. So the example I have for you is over here. find the value of x and the length of segment ST if t is between s and u. ST is equal to 7x, SU is equal to 45, and the length of segment TU is equal to 5x minus 3. Okay, so when we do this problem, it is very important to label the picture, okay? Otherwise, it gets confusing. So the length of segment UT, it's 5x minus 3, okay? The length of segment TS is 7x, but we also know that the entire segment US is equal to 45 units. Okay, so now the equation I can write is this: UT plus TS is equal to US. And now let's substitute. I can replace UT with 5x minus 3. Okay, plus I can replace TS with 7x. I have additions, I don't have to use parentheses, and the length of segment US is 45 units. Okay, now algebra, 5x plus 7x would be 12x, so you get 12x minus 3 is equal to 45. Add 3 to both sides, 12x is equal to 48, and if you divide both sides by 12, x is equal to 4. Okay, please do not forget, check the question again. Find the value of x. So I found that x is equal to 4. And then find the length of segment ST. Okay, ST is this segment. So we know that ST is equal to 7x. Therefore, ST will be equal to 7 times 4, which is equal to 28 units. Okay? Very important example. Okay, the next example is challenging because we did not give you a picture. So we will do example A, okay, and I will walk you through the steps. So question A. Before we do question A, we have 3 directions. Find the value of n and the length of segment WX if W is between x and y, and WX is equal to 6n minus 10, XY is equal to 17, and WY is equal to 3n. So the most important part of a sentence is this: W is between x and y. So this means that 3 points are collinear and W is between. So if I draw a picture, okay, if I call this X, if I call this Y, now when I say W is between, that doesn't mean that W is exactly in the middle. Doesn't mean it's midpoint. We never define midpoint yet, but in between means it could be somewhere here. Now, our picture is not to the scale. So that means if I do the problem and finish it, my answers may appear to be incorrect because the way I draw it, but that's okay. Okay, the picture is here to help you. So let's see what we know. WX is 6x minus 10. Okay, label the picture. That's the most important thing. Segment XY, which is the entire segment, is equal to 17. And WY is equal to 3n. Okay? So that's the first part of the problem, to translate the words and label the picture. Now the second thing I will do, I'm going to write betweenness of points. In other words, BOPs. So we know that XW plus WY is equal to XY. Okay? Now let's substitute. XW is 6x, oh, it's actually 6n, I apologize, is 6n minus 10, plus WY, which is 3n, and the length of the entire segment, segment XY, is equal to 17. Okay, now it's algebra. 6n and 6n and 3n, that will be 9n. Plus 10 to both sides, it will be 27. So now if you divide both sides by 9, n will be equal to 3. Okay? So the question was find the value of n, so n is equal to 3. Okay, next part of this lesson, very powerful statement, very powerful definition, congruent segments. Okay, in geometry we say that triangles are congruent. In algebra we say numbers are equal, but in geometry we say triangles are congruent. We say segments are congruent. Okay, so what does this mean? Congruent segments are segments that have the same measure. Let me repeat this again. Congruent segments are segments that have the same measure. So let's take a look at segment AB and segment CD. Okay? Segment AB is equal to, the measure is 1.7 centimeters. Segment CD is also 1 7/10 centimeters. Okay? So as you could see, they are exactly the same. They have the same length. So in other words, segment AB is congruent to segment CD. Now, I don't know if you noticed, okay, in geometry we use specific notation, the 2 tick marks. Okay, segment AB we placed 1 tick mark, segment CD we also place 1 tick mark, and that indicates that the 2 segments are congruent. Okay, so every time you see tick marks, and for example, if I give you this segment, okay, if I put 2 tick marks, and if I give you this segment, if I also put 2 tick marks, now if you look at the 2 segments, you may think that the second segment is a little bit longer. No, in fact, because I'm putting the tick marks, that indicates that the 2 segments are congruent. So remember, congruent segments are segments that have the same measure. Okay? So in this example, we have a hexagon, okay? And the question is, how can we tell which segments are congruent? Okay, so how can we tell? Look at the tick marks, okay? Segment BC, okay, and segment FE, they have 2 tick marks. Okay, so we can say that segment BC, okay, new notation for you, equal, but I'm going to put squiggly line, like similar or approximation, segment FE. Okay, so this symbol for the first time means congruent. Okay, so we know that segment BC is congruent to segment FE. Also, I see that this segment is congruent to this segment, congruent to this segment, congruent to this segment. How do I know it? Each segment has 1 tick mark. So I can also say segment AB is congruent to segment AF, is congruent to segment ED, and is congruent to segment CD. Okay? All right, excellent. And to finish the class, to finish my lecture, we have for today, and fortunately or unfortunately, it's the most challenging, but I love it. If you look at the picture, you see x squared or n squared, so automatically think about quadratics. Okay, so find the measure of each segment. So what does this mean? You have to tell me how long is segment MN, how long is segment NL, and then how long is segment ML. So the first equation you can write is MN plus NL is equal to ML. Now let's substitute. MN is 7n squared minus 45n. NL, which is this segment, is 3n squared minus 20n. and the length of segment ML, the entire segment, is equal to 35. So now I have this long quadratic equation, okay? But we can simplify a little bit. 7n squared and 3n squared becomes 10n squared. Negative 45n minus 20n is negative 65n, okay? And equals 35. So next thing I will do, I will put 35 on the left and make it equal to 0. Okay, so you get 10n squared minus 65n minus 35 is equal to 0. So how do I figure out the value of n? Now I can look at GCF. Okay, 10, 65, and 35, I can factor 5. If I factor 5, I will erase this. I get 2n squared, okay? 5 times what is equal to 65? I think it's 13. 13 times 5, so that would be minus 13n. Okay, 5 times what is negative 35? That will be minus 7. And this will be equal to 0. Okay, now I can divide by 5. So I get 2n squared minus 13n minus 7 is equal to 0. Now the question is, how do we solve this quadratic equation? Okay, I recommend that you use quadratic formula or factor. Again, this example is challenging, but I still want to challenge my students. So if you want to factor this, okay, you get 2n and n. Negative 7 is 7 times 1, so I will do 7 and 1. And now think about the signs. To get negative sum, okay, I have to make this negative and this positive. Again, how do I know this? I just I just did the factoring in my head. But again, if you're confused about this, I wouldn't stress it. You can also use quadratic formula. So now I get 2n plus 1 equals 0, or n minus 7 is equal to 0. Okay? So if you finish the problem, you get 2n equals negative 1, which means n equals negative 1/2, or n equals 7. So I have two solutions.